All right, everybody. This is Jennifer from the New Haven Free Public Library here with Paige Swanson, and we're going to be starting our next session of Learn to Code. So if you have any questions, feel free to put them in the chat if you are on Zoom. Otherwise, you can put them in the comment section on Facebook and we will get back to you. All right, Paige, you are good to go.
Cool, thanks. So like Jennifer said, I'm Paige Swanson. I'm a full stack web developer by trade, I guess you could say. I work at a company in Raleigh, North Carolina called Abrigo. It's like a financial services company, but so I mean, this series has been going on for about a year. So if you're just joining now, we're doing specifically some instrument stuff, working with Pure Data, which is a graphical programming software that we've kind of been learning about for the past like month. We've spent time on doing a variety of different kind of tasks with Pure Data, some very like audio focused and some of them just kind of like understanding, helping us understand how Pure Data works as a graphical programming language and how Pure Data kind of lets us build systems. So I had a couple of things kind of queued up for this week, in particular, some audio effects. So just like kind of playing around with different audio effects using Pure Data. Since, since we, we basically spent a lot of time in the past couple of weeks building these instruments. I was gonna see if anyone is in the Zoom or anyone had any particular like, what am I looking for? If anyone had any particular incentives to, kind of direct the class on maybe messing with or updating or advancing some of the instruments we've already made. But I think it's all pretty much new faces. So, which is fine. So I think maybe, I have this lesson kind of prepared to look through some of these audio effects. So if everyone's kind of okay with that, maybe we'll just go ahead with that and check some of that stuff out. So this should be relatively beginner friendly. It's just kind of like new concepts. It's not necessarily building too much on what we've already done. So if you're not in particular familiar, that's totally okay. So to start off with, basically in Pure Data, we're trying to build things that can kind of produce audio sort of like all on their own. That's kind of one of the main drivers behind Pure Data is instead of, building an instrument that requires a lot of my input or a lot of my suggestion, I want to make instruments that can almost like kind of play themselves. On top of that, Pure Data, the software, which I have open over here, is gonna, that actually looks pretty good. Okay, great. On top of that, Pure Data is graphical. So whenever we automate these instruments, one nice thing about it is that it's really easy to make like controls and very intuitive like ways to interact with our automations. So that's kind of a cool aspect of it. So that being said, something that I think is like a common, I guess, like interest for, working with audio would be like effects. So, effects can make things very interesting. It can kind of augment or change the way that an instrument sounds or even, behaves for the user, especially when it comes to like time-based effects or, effects that make the instrument change its sound over time. So I wanted to just demonstrate a couple of these effects just as a general survey of effects, and maybe people following along can try some of these effects out on their own as they're working with stuff. So if you're working on a library computer, you should have Pure Data up and running. If you get that, if you're able to get that going, then basically we're just going to open a new file up at the top left here on a Mac if you're doing that. But on Windows, it should look pretty similar. So just file new. We'll give you this kind of like blank patch. And then what I'm going to do is start with a couple of like very basic components that I'm going to use to not only listen to the audio, but also to demonstrate it. Okay, so first thing I'm going to do, actually, I used a shortcut there, or a keyboard shortcut. I'm going to try to not do that because it's not super helpful. So first thing I'm going to do is I'm going to put an object. Okay, and this object I'm going to call an OSC for oscillator. So I mean, this is just a really nice little convenient sound making tool. I'm also going to zoom in because that's very small. Hopefully everyone can kind of see that. Okay, so we're going to start with this oscillator, very basic. And this is going to produce an oscillating wave. And if we give it the right frequency or sort of recurring rate for the wave to follow, then we'll be able to hear it. So let's give it arbitrary value, maybe just something a little off convention. I don't know. And again, I used a keyboard shortcut there, but we're going to add a new object. So I've got my oscillator with the frequency. So I did that by going to put object at the top, and then I get a little box to click and drag around. And now what I'm going to do is add another object with a star, so like the asterisk. So on most computers, if you do Shift 8, you'll get that. And then we're going to add this little squiggly tilde, which we added to the oscillator as well. I didn't really go into too much detail there, but essentially that means that we're working with audio. So if I didn't want to work with audio and I wanted to multiply like two numbers or add two numbers, then I wouldn't use the tilde. So just to quickly demo that, I can put a number and put another number. So just grabbing from the drop down there, and it'll actually automatically connect them. I don't want to do that. So if I put these two numbers together into this object, like with these lines, then, oh yeah. Yes, yeah. That is just a kind of a shorthand by default. Like pure data assumes that if you try to put a bunch of objects in succession, it's kind of going to assume you want to connect them all together. So if I do that again, and it'll just start connecting them all in the chain, which can be nice sometimes, but in this case we don't want them connected. We want them to go into the inlets here at the top. So inlets, like INLETS, like inputs basically. And so this is going to act like a multiplication. And to kind of see what the result of that multiplication is, I'm going to connect to the output. And all I need to do is basically change this number here. And the way I do that is on a Mac, I can do Command, click, and drag. And on Windows, you do Control, click, and drag. So Control, click, drag up and down, or Command, click, drag up and down. And then, of course, this is 0 because I haven't changed the right-hand input. But you'll also notice that if I change this right-hand input, now it doesn't do anything. And that's because it's only going to respond to changes at the left input. So this is a kind of a quirk of pure data where you need to send changes to the left side input to actually make the function do something. So now if I change it, it's going to update. So 12 times 12 is 144. So all of this to say, the only reason I'm demonstrating any of this is to show you that you can do, all of these kind of math operations on just, basic numbers. But what happens when you start working with audio? So instead of multiplying two numbers together, if I instead add a little squiggly here or a tilde, and I put in an audio signal, a couple of things to notice right off the bat. you'll see if I move them together, it's a little more obvious, but like you see this line is thinner than this line on the left-hand side. So that means that we're working with audio. It's like another way of pure data telling you like this is an audio signal, like you're going to be able to hear this. Whereas a thin black line is just going to be data, so it's just numbers. And there's a couple other ways that audio will behave a little bit differently, but I think this is a pretty good like a good survey of that stuff. So we don't really need this right-hand side anymore. Oh, can you see this over there? Oh, you can? Okay, good, cool. Oh, there, yeah, nice. Okay, good call. All right. You what? Oh, your multiplication. Did you try adjusting the left-hand number after you adjusted the right-hand number? Oh, wait, let me undo. All right, so you got your left-hand number, you got your right-hand number. But if you change the right-hand number, well, this is a bad example because the left-hand number was also 0. But if I change this right-hand number, like the multiplication won't update until I change the left-hand number again. So if I go to like 20 and I go to 5, now this will update. Oh, great. Okay. Yeah, so to be a little more detailed, the way it's working is basically this object in the middle, this multiplication. When I send a sort of what pure data calls a bang, which is produced by anything that changes, or there are also objects that specifically send bangs. But the real key idea here is really anything like changing sort of by my actions or something automated. That's what's going to force this function to execute this multiplication on the left side, but just anything coming on the left side. If I just send something to the right side, nothing's going to happen. And that's because typically pure data reserves just the left little input for like updates responding to change, but like the right hand and onward, like if this had, let's find an example. So trying to think of an object with more than one input, maybe like I think like select. Oh, that only has 2. Let's see if I can remember one here. If we go to help, we can look at a list of objects actually, which will make this a lot easier. So if you go to the top and click help and then list of objects, you can see all kinds of different objects. So like one, for example, that would work a little bit differently. I mean, as you can see, most common objects only have like maybe 2 inputs. Sometimes they'll have a lot of outputs, but it's a little more rare. Okay, here's one. So like this V-line object, and again, I'll try not to use shortcuts here. So put object, I'm going to say V-line. So this actually has 3 inputs. So the reason I bring up this example is because basically all of these right-hand inputs, they're not going to respond. Like if you send changes to them, it's not going to make the V-line function do anything until you send something to the left. But what will happen is these right-hand inputs, they'll remember what you sent it. So it's like almost like, to make a long story short, basically the right-hand one is like just remembering. It's just keeping it in storage. It's saying like, you've sent it to me, I see it, but I'm not going to do anything with it until I'm told to execute. So I can change this all day, and it's not going to do anything. But then as soon as I change this one, it remembers that this was 48. And now it's going to multiply by 6. I guess a really good way to clarify this would be like, if I change this to 50, and then I delete it, if I change this to 5, it's still remembered that it's 50, even though I deleted the 50. But it's just remembering. Yeah, I wish it was, to be honest, some of that stuff cannot be very intuitive, but especially if you're new to pure data, it's like a very goofy system, but it works in a lot of ways that helps us automate things and have a lot of control over our automation. So, all right. So, oh yeah. So we're gonna continue with the audio pathway here. So, I guess that kind of brings me to why am I even multiplying this oscillator in the first place? So, why would I want to do that at all? Well, I could explain it, but I think the better way is to like look at it. So we're going to try to visualize this really quickly as well. So by default, let's just go ahead and do the multiplication and the little tilde. And we're going to do this by 0.1 here. So instead of adding a number in to the right-hand side, we're just going to write explicitly a 0.1, which means just multiply by 0.1 instead of having to send it in. We could also send it in. That's not a problem. So we could add a number, and I could connect it. And what I'm going to do is do Control-Shift-Click and drag to do really small changes. So I can adjust this to 0.1. So and then I could delete this if I want. So now I can just use this number box to do that. It doesn't, either way, it doesn't matter, but I usually like to just do it like this because I'm not going to change this one. Like it's probably just going to stay the same. So, but it's nice to be able to change it. Last thing we're going to do to get this audio to come out, and I used a shortcut there, but we're going to put an object and we're going to call it a DAC. So this is a digital analog converter. So the goal is to basically get this signal, which is in here somewhere, and to hear it on our computer speakers. So I'm going to connect the output here and connect this output here. Oh yeah, the DAC, it's an object. So if you go to put, yeah, yeah, and again, any of these that are square, like all square edges are always objects. If you get a bit lost, like reading these. So if you just see a full rectangle or a square, it's just an object. And then this one is a number box because it's got the little, like the fold at the top right. Oh, you mean when we had like oh, I see what you're saying. You mean like these? Oh, like this part. Oh, yeah, I see. Yeah, they are little boxes. Yeah, so what happens is when you put an object, it will resolve the name. Yeah, so when you add the string in, it'll look it up inside of Pure Data's like library and say, "Oh, I know what you're talking about. You mean this one." And in fact, I can like make one up. I don't know, but it won't work. It'll just stay like that, and it'll say, I think it'll even say in the log. If I go back over here, yeah, it says couldn't create bub. So, can I zoom in on that? No, I cannot. So yeah, okay, so that's how that works. But so we connected our audio output, but I just want to point out, like obviously we can't hear anything. If I hook this up here and I click DSP on, if you're in the library, oh, you still can't hear anything because I have my headphones in. Hold on. Did that work? Oh, you can hear it? Oh, great. It's also in my headphones, which is funny. Yeah, weird. Okay, well, that's kind of good, I guess. Okay, great, but that's a really annoying sound, so I'm going to turn it off. So the DSP checkbox over here is your friend. Anytime you hear audio and you're like, this is terrible, just remember the DSP checkbox. Sometimes stuff can get very loud. Okay, so now we have what I'd like to call, I guess, like as a pretty essential component of PD, like these kind of three these kind of three objects together, if you begin working with pure data generally or PD, then you will do this a lot. You'll do this all the time because it's very useful to make stuff like this that can make a quick tone. Yeah, so in order to make different like tones at different pitches, so different frequencies, I can just change this number. But to make different types of tones, I might need to change the type of signal that I generate, or rather change like the source of the signal. So this is an OSC, but there's other ways to make different types of sounds too. So if I want it to sound a little bit, crunchier or something like that, then I might need to use something different. But actually, some of the effects we'll look at will do this. So that's kind of a cool segue. But first, I think before we apply an effect, it's going to be very useful to see what this looks like, see what it looks like as best we can. I mean, we can't really see audio in a really meaningful way, but we can at least try in two-dimensional space to see what a wave sort of looks like. So to do that in PD, we're going to add another pretty crucial little tool. This is called tab read, or tab write actually. And it's going to have a tilde. And the idea is that, we're going to basically write the content of the signal that we're producing to a table or an array, basically a set of values. And then we can view those values in a little display. So I'm going to do that really quick. And there's one more thing I need to pass here, which is the name of the place that I'm going to store these in. So I'm just going to call it like signal underscore table. So this is all good. We're going to just send that in there. But the problem is that we don't have somewhere that we're sending this to named signal table. So we need to create that. So to do that, I'm going to do this put. And I'm going to put an array, which is at the very bottom of the put menu here. And if you've been in a previous class, you'll remember doing this, but I do this all the time because it's nice to see what stuff looks like. So in this little array properties window that came up, I'm going to match what I wrote here. So I'm going to call it signal underscore table. And I'm going to leave the size as 100. But actually, no, I'm not. I'm going to jump it up a little bit. I'm going to go 500. And I'm going to leave it with points. And new graph is OK. So I'm going to hit OK. And that'll make this big like black line in the middle of your screen. So this is where all the data that we're storing from our signal is going to go. So you'd think we'd have everything that we needed. I mean, we hear the sound. It should be producing a signal. But the problem, if you're around before, you might remember this issue. The problem is that this little function doesn't know when to write the data to the array. Like we're just telling it what data to write, but similar to the problem with the multiplication, we have to say like, okay, go ahead and write it. So what we need to do is kind of a little hack. It's not really a hack, but it works really well. Basically, we're going to make a metronome object, which is basically just going to count off time for us, and it's going to do it regularly. So I don't remember if I put that or not, but again, this is an object, so everything in a rectangle is an object. And I'm going to put that, call it metro. I think you can actually say metronome too. And I'm going to give it a time which to count off. So basically, the time that I put is going to be the time between each count in milliseconds. So if I say 500, then it's going to count every half second. Okay. Oh, it didn't work. Okay, you have to say metro. Go figure. All right. So that resolves looks good. If we connect this up to the tab right, okay, that should work as well, but still we're not getting any updates. So we have to do one last thing, which is a bit silly. We're going to put a bang, and the bang is basically just going to turn on the metronome. So the metronome, when you add it to your patch, it's just off by default. So we're going to turn it on. And we're still not going. It's very possible I messed something up, but could be that. Yeah, okay. You also need to turn on DSP because basically it's not going to update. The signal isn't actually doing anything unless you have DSP enabled. So as soon as we enable that, then we can see everything in our table, which is very, very useful. So now, basically, we will be able to actually like visualize what our effects that we're going to create are doing to this wave. So this is very useful tool. And what I might do actually is like I'll save this patch because like 9 times out of 10, if you're working in PD, you're probably going to do something like this when you're building your instrument, because it's just so useful to, of course, generate audio, but also to see what your audio looks like. So I'm just going to save this, and I'll just call it basic patch. And I'm just going to save it somewhere. Okay. Now we have a really basic patch. It sounds good. Oh, so that is why you do the metronome. Did you hook up the metronome? Oh, you did. Oh, yours. Yes. Oh, yeah, that might be. Let's see. It should move a little bit. You could probably choose a signal frequency though. What is your metronome time? Oh, it's 500. What is your array size? If you go to properties, is it 500? Oh, right click. Right click the graph and go to properties. Yes, signal table. Yeah, right click on signal table and click properties, and then you should see something come up that says size, like that. 500. Okay. Well, that's interesting. You have DSP on? I hear yours now. Oh wait, let me turn mine off. Yeah, that sounds like you. But okay, let's take a look really quick. So the wave is not moving. Maybe if I look. Oh, you know what? You're using the browser. I wonder if it's like, yeah, it's like might be kind of hard to explain, but maybe it's going so slow, the browser, that it doesn't update very quickly. But try changing the itself. So turn on YouTube and the wave changes. We can. Oh, I guess. Yeah. Okay. Yeah. Yeah. 200 hertz is a good hertz. All right. Okay, so basically what happened is So Celeste is using the browser version of Pure Data, which I've mentioned before in class. If you don't have Pure Data set up, there's a browser version, but basically the browser is so slow that it like wasn't updating the waveform regularly enough. So it looked like it was just frozen. So that's a good tip. If you're using the browser version, it might like look like nothing's happening, but it's just because the browser can't refresh that quickly. So like if I turn DSP on again, like this, well, this one's not moving very fast, but like if I do like, I wonder if I can do this live. If I update this array to have a lot of data in it, yeah. This is like moving pretty regular, like it's updating a lot of different values over time. So there's a lot of changes happening. And then if I update this to be even faster, even my Pure Data, like it's like, I give up. I'm not going to do this for you. But yeah, just something to keep in mind. Okay, so we got a nice visualization. We have an audio tone. So now we can start doing some effects. Okay, so the first effect I wanted to talk about is, I think, something probably everyone is familiar with, which is clipping. So clipping, if you've ever like had the volume really high on your phone and you play like some audio and the audio you're playing is really loud and it starts going like it's you like it doesn't sound very good. Some people would argue it sounds really good, but up to you, personal preference. I think it sounds pretty good when that happens, but that's what clipping is, or you've definitely heard it, is what I mean. So I have this little, just a Wikipedia link. Oh, and by the way, for everyone at home, I don't know why I didn't introduce with this, but hopefully you saw the URL and kind of put two and two together. But I am at this URL here, so github.com/Paige Swanson is my notes if you want to like, if I move away from something that you were trying to read, so just in case. And then you can go to PD instrument course. And we're on session 4, but okay. So I have this little link in here just looking at Wikipedia, which is a pretty good source for a lot of stuff like this. But basically, it's just kind of demonstrating what clipping looks like. So, you know, now we're pretty familiar with what waves tend to look like if they're visualized in a 2D plane or a graph. So then you can kind of imagine like what's going on here, right? Like it looks like basically looks very similar to the wave that we were dealing with. In fact, I'm going to make this smaller. I'm going to hit OK and set this at like 500 again. Actually, that's pretty slow. Leave it at 200. And I'm going to make this, I'm going to reduce the frequency on this by a lot because I just want a really nice, oops, turn on DSP again. Yeah, I just want a really nice looking sine wave. So you can see here to a degree like how this compares with our visualization of our wave. So like you see, this is kind of like a flat top. Basically, it almost looks like this wave got like a haircut or something. Like it's very flat at the top where it should look very smooth. And basically, if you're looking at this, you basically understand what clipping is. I mean, that's what clipping is. So in the notes, I tried to create a little sort of example, a sense of like what's happening when you're clipping. But basically, the signal is maxing out at a certain threshold. So if we imagine our signal here, let's imagine that the top of the graph is the number 1, and then the bottom of the graph is like -1. So the idea behind clipping is that basically, when this signal tries to exceed any value above 1, it's going to get cut off. So it's just we're just going to cut the top off. But I think the real kind of interesting part is like what that sounds like. So how do we start to listen to what that sounds like? So let's set up some clipping. So first thing we're going to do in Pure Data, and I give you the kind of object to work with here. So in Pure Data, the way that we can do clipping, at least very easily, there's other ways to do it, of course, but one way you can do it pretty quickly is with the clipping object. I'm going to put an object, and I'm going to call it clip. with a tilde. Oh, this actually has 3 inputs. So there you go. And I'm going to click help because, just generally, this is a very useful thing to do. So I'm just going to see kind of like what clip is about and what I need to provide it. But I recommend doing this with any object in pure data. It's not worth your time to remember what every object in pure data does. So it's better to just kind of vaguely remember and then just take a look, because their documentation is really helpful. And usually it gives you examples. So in this case, it's basically doing what we described. We're going to restrict a signal between 2 limits or 2 values. So if my signal goes from -1 to 1, or I want to limit it to that, those would be my limits. So what we're going to do is, it looks like here, we're going to pass in the signal, and then we're going to tell it what to limit the signal to. So let's try that out. So we have this oscillator here at 220 hertz. So what I'm going to do is I'm going to put this object right here, and I'm just going to get rid of this little line connecting the tab right. So that's so that we update the graph. So I'm not going to update the graph yet. And I'm going to put all my, I'm going to try to organize everything. And I'm just going to generally put all my effects right here in the middle. So that's very clear what I'm doing. So the first thing we're going to do is connect the oscillator to the clip effect here. And then we're going to put 2 things. We're going to put a number here and connect it. And what I'm going to do is I'm going to automatically limit this number by going to the properties. So if you click properties on the number, right-click properties, and I'm going to do lower is 0 and the upper is 1. And what this is going to do is basically make it such that this number can't go outside of that, which is useful when you're controlling things, because sometimes you drag a number and it just goes haywire. You drag it like to 100, and you didn't mean to do that, so it's helpful. And then what I'm going to do actually. Well, first I'll go ahead and put another number for this part. And for this one, I'm going to do the opposite. So I'm going to say the lower is going to be -1, and then the upper will be 0. So I'll click OK there. So you can see basically when I click and drag, it's not going to go above or below those limits that I set. And same thing for this one too. So this is pretty nice. And then finally, what I'm going to do is I'm going to send output of the clip. I'm going to put that into, well, I'll put it into the tab right here. And then I'm going to move this part all the way down so that I have some room. And I'm actually going to delete this connection, this main connection from the oscillator. So right now, if I turn DSP on again, you'll see that the clip is working, seemingly. But, oh, I flipped these around, by the way. We're going to fix that. But so you'll see the clip is working, but like the tone is this, like it's not changing the tone at all. That's because I have to delete this main connection to the audio out, so our DAC. And I got to put the clip there instead. So that's the last thing I got to do. But before I do that, I'm going to not do that because we did the clip wrong, and that would not be a fun experience. So what I did wrong was I put these limits. So from 0 to 1 and 0 to -1, I need to flip them around. Because if we look at the properties again, oops. Oh, help, sorry. The left-hand one is going to be the lower, and the right-hand one is going to be the upper. So I flipped those around. So we're going to flip those really quick. So I'm going to just delete these, And the number boxes are still useful. So I'm just going to literally flip them around. Okay. So I'm going to connect this again and turn on DSP. So you can see if I just start messing with these limits, I can already get some pretty interesting effects just going from 1 and -1. And you can, I don't know if you can really hear it. It's a little bit difficult to hear the difference. I don't know if you can hear that shift, but it kind of, to me, it sounds like fuzzy. I've described it as fuzzy. It's kind of like a fuzzy sound. But this isn't really, we're still not really clipping. What we're kind of doing is like, we're kind of like trimming. I don't know. We're cutting off the bottom or cutting off the top totally. So this still isn't, clipping in the way we saw it in this, in this article. If I go back here, open this up. So what we're going for, right? We're trying to like just shave off just the top part there. So how do we do that? Well, first of all, what we want to do is, oh yeah, so you can hear that pretty well? Pretty well? Okay, not really yet. Okay, so that's one thing I think that'll happen when we clip, but that's probably a good thing because it could get loud. But what I'll do is I'm going to edit this multiplication, just bring it up to like 0.4. That's probably pretty loud, I guess. But maybe not too loud, so that's probably safe. So what I'm going to do now is I'm going to Control-Shift-click, or if you're on a Mac, Command-Shift-click. And now I'm going to start messing with this very slowly. And you can almost like, oh, you can't hear it at all. Oh, dang, I thought y'all could hear it. Yeah, that's really weird. What happened? Yeah, probably you're right, yeah. Wow. Sometimes pure data will do that. It'll just give up. It's not in the mood. Hear it now? Oh, let's try this. Okay, there we go. All right, so now you can hear this. So I just want to demonstrate kind of how subtle this is. I mean, this is like basically what some people probably term as like just a pure sine tone. So no effect or anything. It's just a tone, very thin, very kind of clean. But I mean, even just a slight adjustment, like even just a slight clip on the bottom, and then we can slightly clip it on the top too. And you can kind of hear it like, it almost sounds like it's changing frequency, but it's not at all. It's just changing like quality almost. But really, what's happening is, to get a little bit deep, what we're doing is we're actually adding more frequencies, which is kind of counterintuitive because you think we're like cutting off the wave. So you'd think there's only like there would be less frequencies, but if you look at the wave, I guess the best way I'd describe it, what kind of has always made sense to me traditionally is like when you do this, we're adding more frequencies to the wave because a frequency, the occurrence of one frequency, you might describe as like every time this point loops back onto itself, that's like the time it takes for that to happen. That's like one frequency, so to speak. And so this wave, it's like pretty much has one frequency, so to speak. That's not totally true, but like pretty much. But what happens is like when I start to cut this thing off, oops, slowly, now like there's a bunch of values in one place over time that are going to keep recurring. Like, does that make sense? Like this one has a period, it reappears here. This one has a period, et cetera, et cetera, et cetera. So really you have even more frequencies, basically, the more you clip this thing. So that's kind of one way of thinking about it. Yeah, but I mean, I don't know, I like the sound a lot. I think it sounds really good. Okay, so you what? Oh yeah, so let's see. You can try to do that. Yeah. So I was actually going to say, let's try to make this more of like an instrument because, you know, it is kind of fun to move those things. So one thing we can do that we introduced in the last class is we can use a V slider. So if I take this V slider, I can click properties and do the same thing that I did for those limits. I can set the lower to -1 and the upper to 1. And I can even make it logarithmic. Oh, whoops. Upper to negative, except if it's logarithmic, I can't go to 0 because that would be bad. So I'll do -0.01, something like that. Okay, so now I can take this and I can send the output of my slider to this number. And now we have a little control. So it's a lot more fun to play with than just trying to drag a number up and down. And by the way, anytime you're editing, you could just press Control E or Command E on a Mac. And now you don't have to like switch between. You can just, you don't have to hold down a button. You can just drag this. Oh, yeah. So if you do Command E, then now you're just in like performance mode, I guess is what they call it. I usually just basically stay in edit mode and then just hold whatever key like Command or Control. But sometimes it's nice if you don't want to accidentally edit something. Like sometimes you'll accidentally like delete a whole object or something like that, and that kind of sucks. Okay. All right. So, you know, this is our control. And I think basically we're going to kind of stick to having these like little controls so we can keep them around for other effects. So what I'm going to do is I'm going to go back into edit mode. I'm going to like move these over here. Now just move this up, make this a bit bigger. So we'll kind of keep this control around because I could see us using it for a couple of other things. So let's make another one of these. I'm going to just copy and paste it. And I'm going to add it to this one, except now I need to change the bounds. So now the lower is going to be 0.01 and 1 is the upper. Okay, and now we can do the same thing. So now we have kind of a playable, sort of a playable little tool, but okay. So that's, I mean, that's just clipping. So clipping, yeah, it's pretty easy to pull off in pure data. So I want to show off another one, which is pretty similar to clipping, except it like manifests in a bit of a different way. But I would say it's similar to clipping in that I think the effect itself, like the sound that comes off, is not totally different. But it's just, it's a cool visualization, I think. So it's this concept of wave folding, or specifically for this effect, it's called rectification. So the idea is that instead of chopping off the wave, what we're going to do is force the wave to like stand upright all the time. So it's never going to go, you know, sort of down like this past a certain point. So we're basically going to flip it past like 0, if 0 is the middle of this graph. So let's try that out next. So I'll go ahead and save this too. And what I'll do later is I'll put these up on the site. Let's see, wave clipping. And I'll try to put them all on one little thing or something like that. Okay. Okay, so that's saved. turn off DSP really quick. Okay, so I'm just going to delete just the clip, but I'll keep these little controls because I think these might be useful. Okay, so the idea behind rectification, I kind of already mentioned, but the idea is we're going to fold the wave in a particular type of way. So there's definitely a bunch of different ways to do rectification and wave folding in pure data, but some of them involve a couple of different operations all together combined. But I think a really easy way to do it and an easier way to think about it is to use probably what you encountered like in algebra or something like that, this operator, which I'm going to put. So I'm going to put another object, and it's going to be called abs. So I'm also going to add the little tilde like I did with clip, because this is going to be for audio. But abs stands for absolute value. So if you remember from school potentially a long time ago, it definitely was for me, and there's this function called the absolute value, which basically takes any number and it's going to ensure that that number is positive. So if you have a negative number, the absolute value of the negative number is just its positive sort of counterpart. So close that out. That's our little help just to get an idea of what's happening with this function. So what I'm going to do is I'm going to put the oscillator input into this. Okay, and then I'm going to take the output and send it to the tab right. And I'm going to take this and send it into the multiplier. And I'm going to turn down the multiplier before I turn on DSP because I think this one will be a bit louder, but I don't remember. I'm going to click DSP again. Okay, so it kind of sounds a bit similar, I think anyway, to the clipping. It doesn't sound too different. The way we're going to kind of mess with this though is like if you'll notice, it's like all the way above, like it's just at the top there. So what we can do is we can mess with this a little bit by changing the sort of like the content of the wave that rests above 0, and then the content of wave with 0 being the middle. And then the content of the wave that's like below 0. So we'll try to mess with that a little bit. So what we can do is add another operator by adding an object, and we'll do a minus, and then we'll do another tilde. So we're going to basically subtract some audio. And then the idea here is what we're going to do is we're going to subtract up to 1 or less than 1, but not less than 0. Okay, and then what we want to do is subtract from the audio itself. So we're going to send that in. This sounded really cool. I don't know who did that. Oh, it's a printer. Oh. I was like, wow, that was amazing. Yeah, what an incredible effect. Yeah. Okay, so now what we have is we have a little control to adjust where the wave falls across like this, I guess you call it like a 0 crossing, so where it's going to show up. But I guess what I wanted to point out, like this doesn't change the sound at all, at least from my ears. I think if you were using like maybe different, like an analog component or something like that, this could add an effect like distortion if you're changing like how far above 0 the wave is, sort of. But for PD, I haven't found that it changes anything. I don't know if they do something to do that, but that's just a little kind of a cool. It definitely looks cool when you shift it around like this. But yeah, so that's full wave or wave rectification. So it's basically standing it straight up. We don't have a really good way of like comparing it against non, but we can make something really quick to do that. So I think that's where the effect part is going to come in. So basically, this is kind of boring. It's not really an effect yet, but we can make it an effect. We can make it playable. So here's what we're going to do. We're going to use this other fader, is really what you'd call this. And we're going to try to control the mix of the original signal with the rectified signal. So what we're going to do is, well, first maybe we should clean up a little bit. So I'm going to take this, move it over here. I'm going to move these things up. Oops, and I'm going to move this over here. Okay. Now what I'm going to do is, instead of sending this in directly to this multiplier, what I'm going to do is I'm going to add another object with the put. And it's going to be a multiplication object, just like this one, with a little tilde. Except I'm not going to add a number to it. I'm just going to leave it as is. And then I'm going to make a copy of this. I'm going to add another one. And copy that. Okay. And then what I'm going to do is I'm going to add another object, which is going to be a sum. I'm going to add a little plus sign and then another tilde. So what we're going to try to do here is basically make a very simple mixer. And then that way we can mix in an amount of this weird signal and then the original signal. Or we might even be able to do something cooler, but we'll see. So first I'm going to send in the output of the abs object here. Or actually, whoops, I'm going to send in the output of this minus. These should really stick together. Try to keep them together. And actually, let's put it into this one over here on the right side. So let's kind of group all these together. Okay, and then I'm going to send the oscillator into this one. And then what I want to do is I'm going to go down and grab this little control back. And let's actually make it a horizontal control. So I'm going to do a put. And I'm going to do an H slider instead. And I'm going to put it right in the middle. And let's just make this a bit bigger. Okay, so what we're going to do is basically, as we increase the value of this slider, I want basically more of this left-hand side to be present in the output and less of this right-hand side, and vice versa. So that's what I want to happen here. So what I want to do is make, I want to make a connection to this box here on the left-hand side. I'm going to say properties. I'm going to limit it to from 0 to 1, just like I did the other ones. And I'll make it logarithmic as well. Actually, no, I won't. I'm going to make it linear. Okay, so 0 to 1 still. I'm going to click that. Okay, so now what's happening is if we read this instead of this one, it's starting at 0, so there's nothing. And then as I increase it, right, we're getting more of the wave. Oh, you have an announcement. Okay, so as I'm increasing this fader, you can see the amplitude of this oscillator is also increasing. So now what I want to do is I want to mix in this other oscillator, or not this other oscillator, but the effect that I'm applying to this oscillator, the abs output. I want to mix it into this one that I'm displaying, but I want them, oops, no, I do want that. I'm going to display the output here so you can see what I'm talking about. I want them to kind of basically mix together evenly. So now what I need to do is I need to get the kind of like what you call the reciprocal, like the opposite number that I'm using to control the volume of this one, to control the volume of this right-hand side. Because if I just connect this in the same way, now they'll just both be added together and I get a weird, I mean, this wave is kind of cool too. but it's not really what I want. We can listen to it even. I mean, it's definitely kind of interesting, but it's not what we want for this effect. So last step is to delete this last connection here. And what I'm going to do instead, oh, that's kind of weird. Oh, I know why it's doing that, but that's kind of cool. Wow. Huh. Neat. Okay. I to be honest, I don't know if I could repeat that, but that sounds kind of cool too. Okay. So what I'm going to do is I'm going to add another minus audio here. Except it's not going to be a minus like with a squiggly. It's just going to be a minus. And that's because actually it's going to be a it's just going to be a minus. That's because this is producing just a number, this little slider. It's not producing audio. So there's no audio coming out of this. So I just want to subtract a number. I want to subtract this number from 1. So basically, as I approach 1 and increase the value that goes into this object, I want to decrease the value that goes into this object. So what I'm going to do here is I'm just going to send a little, I'm going to do like kind of a hack. So you'll see the hack I'm doing, but it's kind of a little weird, goofy hack. I'm going to make a message with the number 1 in it. I'm going to connect that to this slider. I'm going to connect this to that. And then I'm going to connect this to this right-hand side here. So basically what this is doing is every time I change the slider, I will add a number box to show what's happening there. Move that up a little bit. So every time I change the slider, it's going to show me, it's going to basically send a message to this operator and say, hey, do 1 minus this number. The problem is like kind of what Celeste brought up earlier. If I get rid of this, well, don't get rid of it, but get rid of this connection, it doesn't know, first of all, to perform the operation unless a change happens. So every time I change the slider, nothing's going to happen. And this 1 here, like it's not telling it to do anything. So I got to connect this like that. I got to connect these 2 things so that it tells this message to send to the minus. And I can't make it a number box either, like the others, because if I made it a number, it would change with the slider. So I want to make a message, and the message is up in the put here. And messages are usually just static values, like it's just a value, it doesn't change. And anytime it receives an update, it just says, oh, I got to send what I have to someone else. So that's all that I'm doing there. It looks a little weird though. Okay, but now you can see, right? As the slider gets larger, right? This number gets smaller. So this is perfect for our use because basically now we're going to send that into here. Okay. So now we get the desired effect. So now we can have the full kind of like a maxed out wave looking thing. And we can switch back to the original sound. So we can do a cool kind of little switch between those things. Okay. We've gone a lot over time, but oh, what just happened? Whoa. Okay, we're back. So we went a lot over time, but we got through these 2 effects and showed ways that we can like basically make them playable and enjoyable to use rather than just like effect, no effect, effect. This is often called, in audio, by the way, you typically call this a dry wet, like control. So this would be the dry. So it means like no effect at all. And then this is fully wet. So it means like I'm fully applying the effect. And that's all I'm getting at the output. So this is really useful. It comes up a lot. for a lot of these instruments like this where you want these changes. Okay, well, thanks everyone for joining. I'll upload these in case you want to check them out for whatever reason, and you can reference them. So yeah, thanks for joining and see you next time. Yeah, no problem.
All right, thank you everybody for joining us. I am going to be ending our stream now. Have a good night.